Hi guys, welcome to my coffee break. I hope you've got your coffees ready. This is on Simply Versatile Phased Array Corrosion Mapping, and my name is Gareth Mugford. I'm the product manager for Integrated Ultrasonic Solutions for the Silverwing business unit of Eddyfi. And I'm just going to talk you through today the range of corrosion mapping tools that we have here out of the Silverwing business unit, and the solutions that we provide to you via Eddyfi Technologies. The session will be recorded and available on the website, and you can request a link for that through myself. I've got my email address at the end. Or I can. You should be able to see the link at the end of the slide. Okay, so without further ado, I'll move on to my first slide. So we have three phased array corrosion mapping solutions. R-Scan array, which is the sort of smaller one-axis handheld phased array corrosion mapping solution. It has onboard controls and has stitching functions. So that's your single axis phased array corrosion mapping scanner. And then we have the links unit. That's our latest phased array corrosion mapping scanner. And we have the RMS PA. So almost like a small, medium, and large. Both the R-Scan array and the links are manually encoded, and the RMS PA is fully automated. So a couple of the differences between the R-Scan array and the links. I mean, they're fully portable. So when used with the Mantis or the Gecko, fully battery operated, and you can use it with a manual pump. And you can go about and collect your phased array corrosion mapping scans, and the RMS PA is powered through a 110 or 240 volt supply, and it gives you that ability to control the system with fully automated. So a couple of the advances in technology of late is the capability to remote control the Mantis or the Gecko units, and that we've actually got a blog online which shows that we've got the capability to actually control the Mantis from as far away as you like with an internet connection. So you can actually be connected remotely to the Mantis or the Gecko, and you can control the RMS data inspection. So great if you've got maybe level 1 technicians on site, and whether you wanted to provide some just some auditing or some training, maybe just some technical support. So that just check out the blog online, and there's further information on that. On the R-Scan array and the links. The R-Scan array has been with us now for around about 18 months. It's a great little tool. It runs with a 64 element probe, and gives you approximately a 61 millimeter beam if you're using a 4 element aperture, and you would generally scan in, say, 50 millimeter widths, and you would stitch by increment step, or changing step in incrementally on the index axis on the instrument. So this, of course, a benefit of the R-Scan array is that it's got the buttons on there, so you can actually pause and resume and index step, as well as encoder reset on the buggy itself, which allows unidirectional and bidirectional scanning. When we look at the links is a 2-axis scanner. So for every position, scanner position, you're actually able to collect 500 millimeters of data, and it's in an increment step where the pin drops out and steps into. It's a spring-mounted pin every 50 millimeters or every 2 inches. It comes as standard with imperial and metric bars. And of course, the benefit of all of this is that it's one single probe, one water box, which can be used throughout the 3 scanners. So the R scan array can be used handheld, standalone. It can be attached to the RMS for fully automated phased array corrosion mapping, and the same probe or water box can be dropped into the links. So if you already own an RMS PA and you wanted to concentrate maybe on pipe work with some portable application, because you're going to be out maybe in a pipe rack in a field, and that it was going to be difficult to get power or generator there, then it's the perfect solution to take the links then, a fully portable 2-axis scanner with very low radial clearance. I'll speak a little bit more about the features of each R scan array, links, and RMS PA later on in the slide. So non-intrusive inspection. For those of you who don't know, I'm sure a lot of you will already know plenty about non-intrusive inspection, but it really is now the preferred integrity strategy. With internal visual inspections, or IVI, becoming a last resort to asset owners, mainly due to safety, costly setup, radioactive waste disposal, the time constraints, and the cost of shutting down production. The use of non-intrusive inspections like phased array corrosion mapping have increased dramatically over the last few years. And in addition to the technologies utilised for the NAI surveys, the benefits outweigh visual aided techniques in their sizing and detection capability, given that it's through ultrasonic sort of methodology rather than like a pit gauge or even by just a standard ruler. Before the introduction of phased array corrosion mapping, we would see manual UT scanning or conventional UT scanning, even spot measurements, or conventional UT corrosion mapping, like the single crystal RMS, would have been the preferred inspection methods for integrity assessment of such like pressure vessels, shells, dished ends, and associated pipework. And this was until, as I said, the introduction of 0-degree immersion phased array. So what are the benefits? Huge advantages over conventional UT. There's plenty trials that you can research online, stated as little as 60% POD whilst conducting manual UT site inspection. So a dramatic increase in probability of detection whilst utilising phased array. Higher sensitivity, so it significantly improves sizing capabilities. Of course, all the data sets are recordable, so you can do the analysis offline. You can all the data is post-processable, and also you've got that recordable data set can be there for auditing and training purposes. So the ability to capture data dropout for accurate coverage percentage. Of course, with manual UT, conventional UT, it's very difficult to ascertain how much percentage coverage you're actually getting. Even maybe some of the most conscientious scanner men, UT men, may still inherently drop data due to surface conditions, etc. And obviously with a recordable data set, you're able to monitor how much percentage you've covered, so that the corrosion engineers or whoever is making the integrity assessment understands how much data they've actually collected, so they can make their risk-based assessment. And a volumetric beam. So there's a volumetric beam on the immersion phased array, which provides true morphology of defect mechanisms, because it's essentially a stack of A scans together. Then you're able to picture really what the cross section of the indication looks like, better than in conventional methods. Of course, you get diffractive responses with phased array technology, which also again backs up the probability of detection, that it's capable of detecting misorientated defects, whereas sometimes with conventional ultrasonic methods, it's very difficult to detect because sometimes you can't differentiate between surface condition and a loss of ultrasonic response due to a misorientated or a complex shaped indication where the sound would be scattered. So the R-scan array, our single-axis phased array corrosion mapping system, quick and easy to set up. Got some nice cam levers at the back, which allows the probe to slide in and out nice and easily. Got the improved inspection dexterity, so we've gone for a sleek ergonomic handle design, which makes it nice and easy to move around the vessel, around obstructions, such like nozzles, etc. So you've got that steerability when on a pipe-in or vessel. So one-handed control options, and I already mentioned the ergonomic handle. So we've got 2 buttons on board, as I've already mentioned, that they're pause resume and an index step, as well as an encoder reset. But also, what that does is allow you to have a one-man operation essentially. So you could actually just have the unit set up one side of you. You can collect all your data without having to return back to the instrument. And the air release valves really are they're a fantastic addition to the water box, allowing for a reliable seal and stable signal in any orientation. So you get an inherent problem with when you're at the 12 o'clock position of a pipe. Obviously, with an immersion technique, the air bubbles rise to the top. So the water bleed valves there release that trap there, so that you can get a reliable and stable signal to perform your inspection. And of course, you can attach the R-scan array arrangement directly to the RMS for larger inspections. So then moving on to our 2-axis corrosion mapping system, recently launched. The links, if you haven't already seen the workshop, the workshop is available online. Gives you a greater explanation or more in-depth explanation on the link system, where we look at the corrosion mapping system. Extremely low profile, lightweight design for rope access deployment, and essentially when we're looking at heavily congested pipework or close together, pipe racks, it only requires 110 millimeters radial clearance to get past. It works from 4-inch to flat plate, same as the R-scan array, and yeah, it's a fantastic tool for pipe work, but also can be deployed on vessels and columns, etc. So yeah, it's the design. The key benefit of the design is that it's it's a modular system. It's incredibly versatile. It's the Lynx full system, where we look at Lynx itself, is a modular arrangement, and it allows that flexibility to adapt and customize into whichever arrangement you would prefer. So the Lynx has the corrosion mapping and the weld inspection, 2 dedicated options, and it also has capability to be transformed into, like, say, a single-sided phased array scanner, scan the flange face inspection from the probe sitting on the tapered neck, and the wheels running around the board to give you an encoded B scan. And again, keeping in line with the R-scan array, we've got the onboard controls there. When in corrosion mapping mode, it offers the same increment step function. That when that ties alongside the move of the Aqualock mount into its 50 millimeter spacing, then the button will index step on the instrument for you, also allowing a one-man operation. Incredibly easy to use. It's a toolless design. So for when you're setting up on site, if you want to reconfigure from weld inspection to corrosion mapping, when you're setting up for corrosion mapping itself. The thumb screws on there have been hand plucked so that they're easy to use for a gloved hand, and the system runs really smoothly with the O-rings on the 4 magnets contained within the 2 handle assemblies. On the actual electronic assembly itself, we've got a contactless encoder, and this provides us additional reliability. As we've seen, or we all know in the field, some of the contact encoders fail in the field, and we looked at that through the design stage, and we wanted to try and improve the reliability. So we went for a contactless encoder, which already features on some of the other Eddyfi Technologies products, and have a good track record. So moving on to the RMS PA. So the RMS PA being the R-scan array mounted onto if you've got existing RMS systems, there's a firmware upgrade required on the scanner instrument for existing users, and then there's a bracket to mount the R-scan array probe. So the R-scan array clicks into the RMS. You've got fully remote access, as I've mentioned, so capable of running basically through TeamViewer to like a Mantis or a Gecko. Great for the larger scale inspections, pressure vessels, ship hulls, columns, etc. Really is I think a great tool for phased array operators, so that basically they don't get wet, which is a good one. They don't get as wet as if they were pushing a manually encoded scanner, but also giving you that really fine and accurate drive capability. So it's fully integrated software. So phased array data capture on through capture on the Mantis or the Gecko, but also you've got RMS crawler control through the on board on the Mantis and the Gecko. It's largely unrivaled when it comes to fully integrated automated phased array corrosion mapping systems. Like I say, with the full remote control and fully integrated system, we really are out there as the leaders in the market. We've got so you increase scanning speeds with that. If you want a comparison between single crystal UT and phased array automated phased array UT, it's up to 10 times faster when you compare a 1:1 resolution, and there's multiple scan head options. I've got a couple of videos here. I hope they work. I'll have to just make sure that when I click on them that okay. They look like they're coming out. They're a bit glitchy there, unfortunately. The video is displaying obviously the RMS 450 on site, and how it would appear, in a on such a sort of a column. And then we've got a video here of an RMS inspection being deployed on a ship hull, and you can see that as this perfect solution for being able to control it remotely. You can see there's a tether line there, but other than the tether line, fully remotely operated. And detection capabilities. So phased array corrosion mapping in general. If you're not familiar, general corrosion and pitting, erosion, flow accelerated corrosion, MIC, hydrogen blistering. The early stages of HDHA, laminations, internal coating failures or desponding, and what I've provided there on the screen is a typical display of a C-scan. B scan, D scan, and A scan. So the C scan is the plan view, and then we've got 2 cross-sectional views and your standard A scan trace. And this is just showing some corrosion that is on the test sample, and the colours are representative of a thickness, and you can see that it's in a sort of a rainbow banding. Here that the red would be representing the lowest thickness, and blue representing the maximum thickness. So test specifications: max surface temperature approximately 80 C. Probably could run it a little higher, but then your water is going to hit basically a flash point on the external surface of the test item. Wall thicknesses ranging between 4 millimeters and 200 millimeters. I state 4 millimeters. I've got an asterisk there to state that that's nominal. You can of course inspect lower thicknesses than that, but you just won't have that ability then to size. If you're looking then to size sort of below the 2 millimeter range, you'd be looking at maybe like a sort of a dual linear array, something like something we've got in our Pro catalog, which will be able to give you sizing down to say around 1 millimeter remaining wall thickness. Measurements with or without coating, and minimum pipe diameter of 100 millimeters, 4-inch OD to flat plate. That's specific to the R-scan array and Link CM. Where we look at the RMS, it's 6 inches and up. It's a bit of a lag here, sorry guys. So the next, the perfect NII solution. With the scanners, scanning options that we have now, we really do have the capability to provide you with a full NII solution. So we've got, if we look at the top left, we've got the RMS PA for the vessel shell, the R-scan array for dished ends and around the nozzles. We've got the links in weld inspection mode for your welds. There's even the capability, to run medium range guided wave or Loris probes if you're interested in trying to inspect underneath the saddle supports. And another image of the links where we're set up showing a flange face inspection. And then again a couple another image of the links for the associated pipework that would be linked to the pressure vessel, and of course the links in corrosion mapping mode, again for associated pipework, or of course the vessel shell if you wanted it to be portable, and if you wanted a manually encoded option instead. So complementary systems to these corrosion mapping systems that I've talked about. We got the Lynx WI. So again, the Lynx full arrangement, which we designed, is 2 dedicated systems in one. Really does complete the sort of NII solution package, and the PipeScan HD for rapid screening of long pipeline lengths. So we deploy, the PipeScan HD in such pipe racks for rapid screening. There was a coffee break from the main man, Lloyd, which showed I think qualify before you quantify. So yeah, you'd run the PipeScan HD to qualify or to screen, mark up the areas where you had indications, and then use a phased array corrosion mapping system to quantify or get quantitative results in those areas. So that's the couple of the options that we've got here. That's the end of the presentation, but I'll quickly demonstrate now the R-scan array, and switching over from the R-scan array to the links, showing you that again that the probe, the versatile solutions. if you had, if you're an operator on site and you've got an R-scan array along with a Lynx or an R-scan array along with an RMSPA, you really are able to get probably the most amount of encoded data that you could possibly hope for. And at the end of the demonstration, we'll just have a Q&A session. So I just need to swap my mic over to the USB mic. Apologies, you can't see the screen very well, so we'll have to make do. I'll first just display the R-scan array. We'll just get some water going. So like I said, we've got some nice easy cam locks at the back to remove and place the probe into the main body of the chassis of the system. We'll just come down here. Hopefully you can see my screen, and we'll just reset the encoders and play, and then we'll push the increment step button and move the R-scan array, and we can just build up our C-scan, and hopefully you can see the defect. There we go. Okay, nice. So just have a quick look at this data set. Okay, hopefully you can see my screen. Unfortunately, it may not be great resolution. We can see the nice B-scan image there of the indication, and the C-scan being displayed nice also. We can just go into the palette and choose a nice rainbow palette, which is my preference, and then we're able to move the color palette to suit and give us our high and low parts of the C-scan itself. So if we want to then swap over to the Lynx, you just, as I said, loosen off the R-scan array, the cam locks, and the probe will comes out of the R-scan array buggy. Then we mount it into the Lynx. Just knock the water back on. We'll just change over the encoder leads. And then load our setup. Okay, straight to inspection. Okay, we got a nice signal there. We didn't do a setup, so hopefully it's okay. Okay. Oops. Sorry, one of my cables isn't plugged in quite correctly there. Lucky this isn't live. Okay, we'll just go back to the bottom. this again. Go again. Play. Okay. An increment step. Move the scanner. Oops. Increment step. Use the scanner. See a nice defect. Just going to stop that. Seem to be losing some coupling there. I don't know what's going on today. There we go. So you can see a nice defect there. Apologies, I haven't gone exactly to plan. But that's the main operation of the link scanner. As you see that I've engaged the brakes there, and it's nice and it's a nice and easy system to use. I'll just come back to my laptop now, and if you guys have got any questions, then I'm sure to help as best as I can. So one of the questions, and what are the advantages or differences between R-scan array and link system? Can you give more details? So the R-scan array and the links, as I mentioned, the R-scan array would be used sort of around on dished ends, like a petal scan, or around nozzles, close up to saddles, etc. Also can be bolted onto the front end of the RMSPA, and then we'd look at maybe the links for a more sort of dedicated pipework scanner, but also has the capability to scan the vessel shell bodies. Same as the R-scan array. I mean, you can scan in 50mm strips, but you are relying on the scanner man themselves then to keep an accurate line with a fixed arrangement and the increased stability of the link system. You do of course get a you're able to go up and down in a straight line to ensure you're getting that full coverage of the area. And what are the advantages or differences? Okay, that's the same question. Which of these systems is best for scanning non-ferrous cylinders? So non-ferrous items, so like stainless steel pipework or cylinders, you could use both, but with the link scanner, part of the sort of design stage was to build a foundation of different or multiple applications. Really wanted to make sure that this was like a high utilization scanner, so it wasn't sitting on inspection sort of services shelves. And it was out there being used all the time. So part of the next drop that will be coming out is a chain arrangement that will plug directly onto the links, so you don't have to buy a standalone sort of system. They all sort of integrate to one another, and that would be the preferred method then for scanning non-ferrous items. I'll just keep a quick look now to see if there's anything else. If there's nothing else, then we'll call it a day. Of course, if you have any other questions, or if you're not watching this live, then please do email myself, gmugford@eddyfi.com. We can arrange, personal demos, of course, for any of you guys, and we can, have a, hopefully with a WebEx setup. It's a much better setup. It's more personal as well. So you can ask any questions that are required. So that's it from me. So thanks for joining me, and hope it wasn't too long. Yeah, thanks and have a nice day.